Yo, what's up, what's up, what's up? Welcome back, everybody. How's it going? Today we are working on visualizing different types of clustering algorithms. So background is we're working on this like QR code scanner, right? We have this like idealized version of the problem where we've generated a QR code by typing into DuckDuckGo QR code hello world. And here's what we get. We get an image where if you look at like kind of like the outside of the image, it's like kind of just kind of like a white border around a QR code because the spec says that there needs to be some space there. But we have this like idealized version of it where our QR code is perfectly axis aligned and has perfect white and blacks on it. And so what we do right now is we try to find these like corners of the QR code. And then we do that by kind of doing like one-dimensional walks. So we like step horizontally and we say, hey, we're gonna look for this pattern for this like finder code that's like 1 1 3 1 1. Where we're like these ones and threes are kind of like we're looking for ratios of alternating black and white where the center is 3 times as big as the outsides. Great. We do that. We like show these like red dots here where we found all of the cases where that's possible. Then we do the same thing vertically, right? And we have like, these like blue dots that indicate where we found possible areas there. And then we find like the intersections of those guys, and we have these like green dots that are kind of representing that. We also do this thing where once we find the corners, we walk this like timing area in the center and we say like, I'm looking for white, dark, white, dark, white, dark, white, dark. And I have like a kind of initial guess at how big those should be based off the finder size, but that might be a little bit wrong. If the QR code is really big, we need to like account for error in that. And so what we do is we like say, okay, so we're going to walk pixel by pixel and we're going to say how many pixels did it take for each of these whites and darks to alternate? And we'll take the average distance that we found between them, and that's like our module size. Then we can use that module size to like walk the actual data. And so there's like a couple areas where in like a real QR code that might not work so well, right? So I googled QR code bar menu and I found something that looks like this. And on the right here we have like a histogram where basically the farther right you are on the histogram is like brightness values. So like the rightmost column would be white and the leftmost column would be black. And then the height of this graph is showing like how many pixels do we see in our image at that value, right? And so in this image, you see like, okay, so whites aren't perfectly white. They're kind of like a little bit dimmer, right? And we have like kind of like an even distribution of in the white section, there's going to be not the white section of the bar, the white section of the QR code. It's going to be kind of like normally distributed somewhere here, right? And you can imagine that maybe we are on, like, how do I say this? A shitty camera. I have a shitty camera, right? And maybe it's dark at the bar, maybe there's shadows, so maybe we do something like we add some noise. How do I do this? Filters, noise. So like let's pretend that like my camera is kind of shit, right? So maybe we add some like grain because it's dark, and maybe we desaturate it a little bit because this thing's going to be in black and white, but then maybe also we're like a little bit darker for some reason, so maybe we kind of, because the bar is dark, so maybe we kind of do something like this. So maybe this is how like the sensor reads the thing, and now all of a sudden our like darks and lights are like really unclear, right? Like if we select this area in the corner, it's like this distribution is not really white, right? There's a lot of like dark in the area that we would consider light, and we can identify as light in our brains. So maybe you can say, okay, well, what if we like kind of like blurred stuff a little bit to kind of get rid of some of the speckle? So you could do something like a Gaussian blur on like the whole thing, filters, blur, Gaussian blur. And maybe we kind of reduce the kind of strength of this guy a little bit. Maybe we do it like something like this. And so now like our histogram is starting to look like a little more reasonable, but still we have this problem where you can't really just bisect on like the center point of the histogram anymore. You kind of have to identify, okay, so where are our like interesting points? So like what is our dark and is our light, and we want to find like where in here is light and dark. So we kind of need to figure out like, well, there's going to be like visually I can identify that there's like peaks in this thing, right? So another situation where this is relevant, I promise this will come together, is as I'm walking these timing codes, right? Maybe I make a mistake somewhere. Maybe I occasionally accidentally guess too small or too high because there's some noise in this data. And if I'm trying to find like the edge of this thing, maybe it's not like maybe I like fuck up this like color recognition and all of a sudden think that there's like a change in brightness here where there isn't actually one. I need to take like this set of data and discard some values. Another thing where this is relevant, maybe I accidentally find potential finder codes somewhere else in the image that isn't related to the QR code, but I find a lot of them in the finder sections and not so many of them somewhere else. So I kind of want to like take like these like samples of data overall and find areas of high density, maybe discard some of like the outliers and turn those like chunks of points into like single values where I can say this is the center of the finder, this is like a light section of the QR code, this is a dark section of the QR code. I want to like find all those things. And so what we're looking at is clustering algorithms. How do we take individual samples and try to categorize them in some way? And so we have right now is we have like this web app we're running where we can like kind of like generate chunks of points, and we have like a couple clusters that we've worked on. We've looked at this like agglomerative clustering, which says basically as I go step by step, I'm going to take like the two closest points and combine them into one set. And so you run that enough times, you start to get like you start to see clusters form. Right? If you run that too much, everything will merge into one cluster, but you can kind of see that process happening. And we have this like divisive clustering where we start with everything in one cluster and we break it down over and over again into smaller and smaller clusters, basically taking like the cluster with like the biggest diameter and like splitting it up. And so like why are we doing this? Well, we're kind of hoping that by going through kind of like the major clustering algorithms, we can figure out kind of like patterns and like concepts that will help us do this like signal processing in our thing. And so today's plan is to look at k-means clustering and dbScan, two more algorithms, add them into our like list of things here, and then hopefully by the end of that we'll have like a little bit of a better feel for what makes a good cluster, what doesn't, what fits our problems, etc. 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 So that's the plan. That's the plan. I don't have much of a plan other than do the algorithm. And we'll see how far that goes. Maybe we'll get far, maybe we won't. Who knows? So let's look at k-means clustering. So the two algorithms that we've looked at so far, they're kind of like, they're just looking at like proximity of points. So one of them is take two closest points, stick them into a cluster. One is take point that is far away and break it up. K-means clustering is a little different in that you kind of start with the concept of how many clusters do I expect to find. You kind of then just like randomly initialize your clusters and then iteratively try to approach like a true solution. I think this here on Wikipedia shows the algorithm, and it's a lot of math notation. But I think what this is saying is you have some amount of sets that you're trying to create, right? So in this example up here, they're making 3 sets. So your I in this case is like values of 0 to 2 or 1 to 3, right? So for each set, your set is going to contain a given point. X sub p is like like a point. Then this colon is like an if. So he says this set will have this point if the distance between the point and the given like mean. So like your initial guess, you're gonna set like a mean. You have a guess, and you say if the distance between the point and my guess is less than the distance between the point and another guess for all j's and I to k. So I think k is how many guesses you have, right? So you have means from 1 to k. So they're kind of saying here, the point is part of this set if it's closer to this mean than every other mean. Seems reasonable. Then what they do is they say, okay, so now we have these like sets of data, and let's kind of like nudge our points or our means towards the center of this cluster. So I think like intuitively, you might like start with like, you know, points over here and points over here, and you randomly initialize your guesses to like here and here, right? What's going to kind of happen is these points will all end up in like closer to this cluster than this cluster, and all of these points will end up in this cluster. And so then what'll happen is we're like, okay, so we have, well, for this cluster, maybe it'll like contain some of these points as well. Maybe, probably not. But then what'll happen is we'll go, oh, okay, so these points are all for this cluster, but this cluster is like in the wrong spot. So can we like push this over here, and we'll push this one over here, and then we'll go again until the points, the things stop moving. I think there's no guarantee of like stability there. But yeah, we'll see how it feels. See how it feels. So the way our app is structured right now is everything is in this like app class. So we have like a server that kind of wraps our actual underlying implementation, and the server just like sets up some like HTTP endpoints and defines what happens when those points are hit, and then the app actually does most of the work. We have this like clustering interface that basically just has like a next function and a reset and a disable, like I'm done. So what we can do is all we have to do is we have to add in a new implementation of this cluster interface. So we can say somewhere, we're going to say that our k-means clusterer is going to be a struct, and he's going to have some state. He's going to have like his means, which I guess is going to be like an array list of points, probably. Yeah, 2D points. He's going to have to implement our cluster interface. So let's just kind of copy someone else's implementation. So when we initialize, instead of returning our, oopsies, what the fuck did I just do? Instead of returning our concrete implementation, we return a pointer to the cluster interface, and we heap allocate our cluster, and the interface says like, I'm going to give you like a free function. The reason that we do that is because we don't want to have to store the actual implementation anywhere, because then we would need to like make a union that iterates them all, blah, blah, blah. So instead we create this like interface, and we immediately return that. We need to implement our free, next, and reset functions. These are the API that this guy is looking for. And here we're going to replace all of the instances of Diana cluster with k-means cluster, because we are not using the Diana cluster anymore. Hello, I think Centroids is a clearly superior name. Let me think about that. I don't know about clearly superior. They're calling them centroids here in brackets, but I think it is, in fact, the mean, right? The centroid is the mean of all points in the cluster. What is a centroid? Centroid is also known as geometric center. Center figure. Yeah, I guess that is technically what it is. I don't know if I would say, maybe. I don't know about clearly superior. But maybe I will take likely superior. Okay. So this guy has to store the cluster interface. Clusterer interface. Because the way that the C style inheritance, which we're using in Zig, is to say, hey, instead of me flagging myself as a child of this interface, my interface will be a member of my class. And then when I hand out references or pointers to this interface, I can then go from the address of this interface to the address of myself, because I know where the interface is relative to myself, right? Like here, this is going to be like maybe like 8 bytes offset in. So I can take the pointer to the interface, subtract 8 bytes, and then I know where I am. Yeah, so we store that here. Then when we try to free ourselves, we say, hey, I know where I am relative to this, and then I can like destroy myself. Cool. So that means I need to store the allocator that we use to create this guy. Boom, boom. And I think that's most of it. Okay, so when we reset ourselves, what are we going to do? We are going to try to calculate the means. So first we're going to, I guess, randomly initialize this guy. And we're also going to have to kind of set some parameters on him. Which doesn't really line up very well with the interface, does it? Because the interface is kind of saying like, hey, when we reset, we assume that you can derive your state based off of the clusters. But here we're kind of saying, well, we need 3, like say we want 3 clusters. How do we like define that? How do we define that? Maybe, I don't have a good answer for that. You could have like a parameter interface that gets passed in. But this is kind of like one of the reasons why it's sometimes nicer to use unions over like interfaces, because now you don't have to, like, I have this thing that's very specific to the k-means clusterer. Okay, here's what we do. When we initialize our k-means clusterer, we will pass in, yes. We will pass in the initial number of means. Num clusters. Yeah, I think that makes sense. Sorry, I wasn't serious and that wasn't clear. Oh, that's, don't apologize. I mean, I wasn't like, fuck you, you know, it's fine. And then here, when we initialize this guy, our first thing we'll do is we'll take our means. So we'll say var means is stood array list of points. And we'll set the size to num clusters. Okay. So now we have to say the means, boom. And is there anything to do there? No. Okay, then when we reset, our reset will randomly set those means. So I guess we also kind of need like a valid range for each mean, right? We don't really know inherently what the like, how do I say this? We don't know like the bounds of our points, but I guess we could kind of guess it, or we could figure it out by looking at them. So we could go over every single point, and we could say our var min x is equal to, let's say that we're working with, do we know, yeah, these are i32s, so we can say that the min x is an i32, and he's a stood math max int i32. Our min y is also the same thing, and our maxes are going to be the minimums. So here's a min int and min int here. And I don't know if min int is going to return a negative. Looks like it is. Okay, so then we iterate over all points. And we can say, look at the point and assign it to the min. So say min x is equal to the minimum of min x and point x. Yep. And the min y is the same for y. And the max is the same shit. Max. Cool. So now we kind of like know like the range of valid values, and so we can say for each of our means, self means items. So we have our, can I say that I want to take it by pointer? We don't have self here. So here we have our cluster interface. Cluster, and we need to go from our cluster interface to like a pointer to our concrete implementation. So we say that our self is equal to, is a pointer to ourselves. So k means cluster. And this is equal to field parent pointer. So we go, our field name is cluster if, and the pointer is cluster if. Cool. So now we have self here, and there we go. We have this blah, blah, blah. And now we can say that our mean is going to equal, x is going to equal stood math, or stood, ooh, I need a random. I need an RNG in here. So I guess we will take in an RNG, which is going to be a pointer to our RNG. Maybe we'll just make a new RNG for ourselves. That seems fine. Technically, we could reuse the same random number generator that we already have somewhere else. But then we have like self-referential structs, and I hate self-referential structs. So maybe we just copy it or make a new one. We'll make a new one. Fuck it. So we just do this. And then we say clusterer RNG is equal to RNG. Boom. And so in here, now we can say that it's self RNG and random will return something that lets us do something that's like in range at most, which is actually int range. I don't know why it's like at most, because oh, I guess it's saying if like the upper bound is equal to or less than. So here we'll say we can be anywhere in the range of min x to max x, and the y can be anywhere in the range of min y to max y. Yeah. Cool. Cool. And our clusters, we're going to have to initialize the clusters in some way. So I think that the clusters will initially start with, I guess we just call next. We need to initialize the clusters by walking all of the points and assigning the closest mean. And I think that's the same thing that we're going to be doing in the next function. Maybe. We'll find out, though. I could be wrong about this. Not 100% there. So this is cluster IF. This is points as clusters. We have to go from cluster interface to ourselves. And so the algorithm says, for each point, we assign it to a set if it's within the mean. So I guess we have sets, which are our clusters. So I guess on every iteration, we're actually clearing all of our clusters. So do I have a function for that already? No, I don't, I guess. So maybe we'll just have a function clear. And I don't know, he's probably unavailable. And I guess we will... I guess we can just reset the arena. What is our reset modes? Releases all allocated memory, retain capacity, or retain with limit. This will preheat the arena for future allocations by allocating a large enough buffer for all previously done allocations. Preheating will speed up the allocation process by invoking the backing allocator less often than before. If reset is used in a loop, that means after the biggest operation, no memory allocations are performed anymore. That seems pretty fucking reasonable to me. Because here we're kind of saying that like our clusters are going to have the same amount of points as last time. So I think that's fine. What was the options again? It was called retain capacity. Okay, and then we also just have to, at this point, maybe before we do that, we clear our clusters. So can we say clear and free with our... Now, the reason that we're doing this is because we have like a double nested vector. So here we're only really trying to clear the last one. In fact, we can even just say resize to 0 here. No, we do need to clear and free. Yeah, I think we do. Or maybe we just reinitialize him with a new, like a fully new thing. I think that makes better sense. So we kind of say, like, we're not going to bother actually freeing memory, but the arena will just delete everything that is previously allocated, so we don't have to worry about it. I think. Maybe. Say, which means that the first thing we do is we clear the clusters, and then we iterate all of our points. No. We iterate all of our means. Well, let's think about this. He's saying that it belongs to a set if the point is closer than its distance to all over other means. So it kind of makes sense, probably, to iterate by point. And for each point, we'll calculate its distance to every single mean. So we have... our means are an array list point. So here... we could do something like I guess this is a runtime length array. So here we kind of have to make a new runtime length array, which is like the distance to each mean. So here we'll call this a distance to mean. And this will be a std array list of floats initialized with our allocator. And which means that we probably defer distance to means dot deinit. And then you could maybe argue that, like, since we're doing an allocation in a loop, you might want to do something where you like reuse some allocations somewhere. But I'm not going to do that right now. But there's definitely like an optimization here where we don't necessarily want to use like our global allocator on every iteration of the loop. That's probably slow. So we'll keep an eye on that. Yeah, I think. I guess we could also, maybe it makes more sense to do it up here actually. Then we're not allocating every loop. Yeah, that makes more sense. So then on each of these guys, we'll say our distance to means resize 0. So this will make sure that I don't think this frees anything. It will just shrink. Clear retaining capacity is actually probably a more indicative name. This is really what we want. And so then we say for means. Itself means items, I think. Yep. We are going to, I guess we also need to keep the index. And we are just going to populate distance to means. I guess we actually don't need to keep the index because we can just push to the vector array list, whatever the fuck you want to call it, in this language. Okay. So what? There's going to be like average distance to mean, and we're going to take in the mean, which is going to be a point. And then we're going to take in our points. No. No, what am I doing? What we're going to do is we're going to, distance to means is going to be resized. Yeah. Resized to self means items len. And he's actually going to be doing this here. And then at the beginning of this loop, we're going to set all those to 0. Yes. So can I mem set distance to means items to 0? And then for here, we're just going to say distance to means at that given index is add the mean distance to the point. Yes. We're getting there. Then all we have to do is at the end of this, for distance to means items, distance, we have to divide this by something, however many points there are. Yeah. So this is, now we have our average distance to each mean. Is that what we even want? Am I high? Yeah, that's not what we want. We want the distance to each mean for each point. So I'm just mental. I don't know why I thought this is what we were doing. Here I'm calculating the average distance for all points to each mean, which is just not what I want. I guess that's the update step. No, it's not. This is just useless. This is useless code. I don't know why I thought this is what we were doing. What we actually want is just the raw distance to each point and to each mean, and we take the minimum. Yeah. Okay, so for self means items len. Here we need to initialize our cluster so we have one cluster per mean. Clusters, add cluster. Clusters. That does something. So now we have 3 clusters for 3 means, let's say. Then for each point, we set the distance to each mean to that distance, and then we have to find the minimum. So, I wonder if there's some sort of like min, index of min, solid. So we can take each of these distance to means, and we can say which one was the smallest. Best mean. Then, best cluster, I guess we'll call it. Then we'll call clusters, add to cluster, best cluster, and the point ID. Yeah, that seems right. Took a second. I guess you don't need to exclude self since the distance to self will be 0, right? Oh, that's a good point. Do I need to think about that? I'm comparing points there. I think there is no distance to self because I'm not comparing points with each other. I'm comparing points to the mean. And so if the point is exactly on the mean, that's like the perfect distance. So I think that's fine. I think that's fine. Right, because like the distance to self stuff that we were worrying about in the other cases was because we were comparing points to points, and I think we're not doing that here. Okay, so we've like taken all of our points, we've put them in a cluster, and now we want to go through all of our clusters and readjust our means. So that's where the average distance thing comes in. So we say so we'll say var cluster iterator is equal to clusters cluster iterator. And we'll say, while cluster iterator next, we will have some cluster item. And what are we going to do? We have cluster item dot cluster. This is the list of points in that cluster. And we just average them. Yeah. So self means is equal to the average stuff in this cluster. And I think that we have average distance between points. Okay, so we don't have anything that like perfectly matches this. We want average distance to the mean. So we say const cluster mean is equal to self means items at the cluster item dot cluster ID, I guess. And then we are going to say that for cluster item dot cluster, we are going to look at each point ID and the distance. Oh, there is no distance to the mean, actually. We just average the points in the cluster. We don't care about this at all. So, we take the, x is equal to 0. This is average x and average y. For here, we just say self points, or not self points. Points at the given point ID is added to x and y. Right, like this. Like this, yeah. And then we just say average x divides equals by the cluster size. And these probably have to be a float from int as well. Little casting. Careful with empty clusters. This already bites in the past. Oh yeah, good point. if cluster item cluster len is greater than 0, is equal to 0, continue, I guess. I guess we need to do something with the mean in that scenario. I guess we just don't change it. Okay, that seems fine. Otherwise, now we have to set the mean. So, self means items at the given cluster is equal to the average. Is that it? Might be. That might be it. I guess we'll find out. So we also have to hook all this shit up. So we're gonna have a k-means here as one of our options when we set the cluster. If we get k-means, we're going to have to say our new cluster is a k-means clusterer initialized with something. So we have extra values here, num clusters. For now, we'll just hardcode this as 3, just because I want to see what happens. But later, we're going to have to parameterize that. And otherwise, I think everything else might just work. RNG, local variables never mutated, so let's look at this. Const here, probably. Means must be const or comp time. Variable of type? Oh, because I have to initialize this guy with alloc. Oops. Means resize. Oh, so this has to be mutable now, not const. And no field name clusterer interface, because this should be clusterer interface. So in all the places where I said cluster if here, rename it to clusterer. There we go. Okay, error is ignored at line 307, so this should be try. Were there other ones? At mean x, there was at 362, the RNG stuff, I didn't do the full thing, so I think I have to say the type of the thing here. Here I fucked up. I was supposed to write items here. No field named next in app k-means cluster, so that's kind of confusing. Why? Error is ignored at 320. No field named next? Oh, it's yes, there is. Oh, there's not, because the first item is the cluster if. So it should say cluster if.next, like this. Cluster if, I see. I have to access it through the vtable. These guys we need to round and intcast. Int from float, round, boom, boom. Oh my god. Oopsies, what the fuck did I just do? 366, go to line. Try. And value of type bool is ignored on arena reset. What is the return here? This function will return whether or not the reset operation was successful or not. If reallocation false is returned, future allocations might just be slower. Okay, so I don't give a fuck. I don't give a fuck. Okay, we built. And so now we have like a k-means clusterer, and we start with 3 means, and if I were to step this guy, something happens. So let's try to make maybe like 3 clusters of radius 1, and step this guy. Nothing's really happening, which is interesting. Inspect. What is he returning when I hit step? He has 3 clusters, one of which is nothing. So it could be that if the initial state of my cluster doesn't end up with any points in it. My cluster length is 0, and I just never touch it. That does seem like something that we wrote. So that would be this case here, if our cluster length is 0. So maybe what we should do in this case, instead of just not changing it, we should initialize it to another random value. That seems kind of reasonable to me. So maybe we will store the ranges in here. On reset, we will initialize them to garbage values. So these will be like this. Delete. All of these guys say self here. Then here we say self. And here we say self. Nice. What are we using to render? Just like an HTML canvas and some JavaScript. Nothing too crazy. Nothing crazy at all. Okay, and then here, wherever we had this 0 case, we'll just set the thing at that value. So we have means is self, means items at the given cluster item dot cluster ID dot x is equal to this. And we do the same thing for y. Y. Okay, let's try that. So now when we do this, we say, hey, we have some chunks. Let's go to k-means clustering here and reset a couple times. So hopefully now we can eventually get out of the state, and we did, which is pretty solid. So there, what happened was, it's hard to see there, but basically when, how do we come back here? So there's like 2 clumps that are being assigned the same mean. So every time we step here, one of the means is jumping around until it hooks onto some points. So it would be kind of nice to visualize the means in some way in this case. So maybe what we do is our k-means cluster will return some extra debug data. Let's think about this. Okay, so say every clusterer has optional debug data that it can pass on. How do we want to structure that? Because right now, the server is responsible for taking all of our data and JSONifying it. So if we wanted to return arbitrary data, I guess we could just return like a hash map of like, I think I'm going to cheat for now. Because normally what we would want to do, well, I don't know about normally. What I might want to do here is we would want to keep the like serialization maybe away from the actual implementation, right? Like, we don't know that we want to serialize as JSON. We would want to be able to serialize as like whatever. But in order to support that, you would have to basically make a type that you use internally that represents something that can turn into JSON. So you would have to do something like a const, like debug data is some union that is like enum tagged, right? And these things could be numbers, right? And he would be like represented by a float, or it could be a string and he's represented by a const u8, right? Or he could be a object. Maybe use JSON value. So the thing already exists. But then at that point, we already, like, if we're going to use JSON value, then it's like, we're still tying the concept to JSON, so why not just fucking do the serialization here, is kind of what I'm thinking. Right? The reason to kind of split it out here is that you might be able to serial, like, this abstract version could be serialized as toml, as text, as, like, you could render it into a UI tree, whatever. Even though it maps well to JSON. Where using JSON values, you're kind of saying, like, it's actually JSON. Right? And if we're going to be doing that, we might as well just do the serialization inside. That's kind of what I'm thinking. That's what I'm thinking. So that's what we'll just cheat. So what we'll do is maybe we will say we will give you a JSON writer where you can just write whatever the fuck you feel like. So an optional like serialized extra data interface method. Yeah, that's kind of what I was thinking. Like what I've done before. Where did I do this? Fuck, I can't remember. But it's in here somewhere. Let's see if I can find it. This would have been in. I actually don't know. I don't know. It would have been in maybe like the GUI stuff for our debug or our diff tool visualization. I know I've done this before. It was in the terminal emulator. It was in the terminal emulator. I'm pretty fucking sure. Let's see. Probably in the recording subsystem. Yes, this is looking familiar. Yeah. So, in this guy, I had this like snapshot item, and a bunch of my when I was serializing my recording, basically all of these guys implemented this like, hey, I can initialize myself from a snapshot of my data, or I can give you a snapshot of my data. And that snapshot was like some abstract tree that happened in our recording system to be serialized as JSON. So like here we have this like enum snapshot that's like bool, int, string, array map, you know, but like it allowed us to say, if later we decide that our file format isn't JSON, then it's easy to swap out because like this implementation stays the same. The only place where like JSON leaks in is here. So that's kind of like the idea I was thinking of. That's what I would have done if I had infinite time and I wanted to be uber correct. I might do that, but instead we will just cheat. We'll cheat. So here we'll say pub function serialize debug data, and he is going to take in our application, and he's going to take in a writer. And this writer will be initialized into whatever state that he needs. So like if I want to like serialize this into like a specific object, he can do that externally. I assume that this JSON writer is like at compile time typed with the writer, the underlying writer. I'm not actually sure about that. And our cluster will just say serialize debug data. And we'll take in the JSON writer. Okay. Which means that our cluster interface has to have this like serialize debug data, which will take in some clusterer interface as well as a JSON writer. Ooh. This needs a concrete type if it's runtime assigned like this. So maybe, I think that there's a, well, let's look at this. Let's look at what this type is first. Zig standard library. Zig standard library. So he has a JSON write stream, and his output is a write stream typed with the underlying stream. But we can turn this into a runtime type because there is I think I saw the concept of an any writer, which I think takes in any implementation that has a write. So here we can say that we're going to use a JSON writer with an any writer. Let me think about that. I think it's fine. So we can do something like we can like extract the writer from underneath. This is evil. This is also crazy. But. I think what we can do. Write stream from JSON. This guy probably has the ability for us to pull out the underlying guy. Would be my guess. Can we maybe look at the source here? Right. print and object. So all of these guys are going to dispatch the underlying guy. Self value start self stream. Yeah. So we should be able to look at the stream value inside him. Where is my source code? Stream : what the fuck? Oh, here. Yes. So we can take the stream. I don't know if I need to finalize him in any way. Probably not. Doesn't look like there's any caching going on. I also have to take his indent level. This is a little sketchy. But what I'm thinking of doing is we have like externally a JSON writer who is using like a concrete implementation of the writer interface. And I'm thinking, fuck it. We just replace the stream of that guy with a stream of any writer so that we can pass it around to runtime interfaces. That's disgusting. Disgusting. Let me think about, like, is there... Ugh. The other option is that externally we just use the runtime interface for the writer, and then we don't have to worry about it. Let's do that. So we'll assume that this JSON writer is a std JSON write stream given a std IO any writer, and then we can use that everywhere. Fuck it. Const debug JSON writer is a std JSON write stream with a std IO any writer. Not ideal, but we'll live. And then this guy will take in our debug JSON writer. It's fine. We'll make it work. And he will return any error and void. There might be a better way, but I don't give a fuck. So this takes in a clusterer interface as well as the writer. And returns void. And here we just pass along the parameters to the vtable. Okay, and I guess maybe we allow this guy to be null, because most people aren't implementing him, which is an indication that our API is shit, but we've backed ourselves into this corner. So it is what it is. Then most people won't implement him, and when we call this guy, we have to say if self vtable serialize debug data, we get some f, and we call that f here. Like this. Sure, why the fuck not? Now on our k means clusterer. Is this recorded? Yeah, it'll eventually go up on YouTube. So there's a YouTube link in the Twitch description. I don't know about Twitch VODs. So it'll go up on YouTube tomorrow if you want to swing by and catch the full thing later. But as of right now, I don't know if you can like go back in time. I don't know. So this guy's gonna say, I'm gonna serialize debug data, and I'm gonna take in the clusterer interface. Write stream has a second param. Guessing assumed correct will work. Write stream has a second param. Oh, fuck. I see what you're saying. You're saying this guy is a fuck off function write stream. Yeah, okay. Yeah, we'll have to write assumed correct in there, I guess. Thank you. Good eye. And here we're going to take in our writer is our debug JSON writer, blah, blah, blah. He's going to return an any error and void. And we will say begin object. And then we will end an object. All right, and we will put some things in there. So we're going to write our type. So object field, we'll just say type. And we will write the value of k-means, so that externally they know that this is k-means debug data. And then we will write a new field that is our means. And for each of our means, we will spit them out. So here we say for self means items, mean. I guess this is going to be a array. Array and end array with no parameters here. And then for each thing, we just write the value. So writer.write. I guess it's an object where we're going to give it as x and y. So here we have to begin an object here, end an object, and write the x value and the y value. So this is going to be mean x here, and this has to be in a little squiggly probably, and here we're going to write y. What's the difference between any error void and just exclamation point void? So any error is like a runtime castable type. So if I wrote like just exclamation point void, what ends up happening is the function generates a function signature that has all possible errors that could be returned by the function. But since I'm like passing this as a function pointer around at runtime, then it needs like a concrete error type. So any error is this like runtime type that can be cast from any error, if that makes sense. If that makes sense. Okay, so our k-means cluster is going to have our serialize debug data is going to be our serialize debug data implementation, and certainly I don't build because we need to add in our assume correct here. No field named assume correct. What is it? Assumed correct. Wow, and surprisingly everything else is like building. So probably just because you didn't actually call the functions. So here we need to say that this is going to be our debug JSON writer. And then externally, we are going to, in our server, when we try to get our point data, we're going to send data. And our JSON writer is going to come from write data JSON. Yep. Which is all fine so far. And I guess what we'll do is we will take in our app here instead of the points themselves. We can say app points items, and clusters is probably just app clusters like this. And then here we will have a new field that's like debug, or maybe extra, whatever, it doesn't really matter. And we'll say app dot serialize debug data with our JSON writer. And then here we need to create our thing, but by wrapping this guy in our any writer. So var any writer is going to be std.io any writer. And can I just wrap our other writer with this? Is there like an example in here? I assume it should be easy to construct this guy. So it's probably something like context is equal to writer, and write function is going to equal like am I high? Write function is going to be something that takes in self and bytes. So I guess this is going to be just writer dot write question mark, and then we can use this with any writer like this. Maybe. Probably that doesn't build. So write data JSON expects 2 arguments found 3. So here we need to pass in the app instead. Not here. I don't care about my tests right now. Just the actual usage. So here we'll have an app. No function named write on IO writer. Expected const any opaque, so maybe I pass in this as an ampersand. Oh, wow. Okay, maybe that actually just works like that, which is pretty sick. Write cluster JSON expect a pointer. So here I put a little ampersand on that guy. Expected type this, found this. Oh, so here, let's say checked to fix depth as our... Is it like this maybe? There we go. Error is ignored. This is try. And down here, this needs to be try. Wait, that actually fucking runs? Wow, that's shocking. Like, actually fucking shocking. Oh, there we go. Okay, but he fucking crashed. Less shocking. GDB... Zig out. Let's look at this guy. We hit run. We refresh. He gets mad. We backtrace. We go to frame. So what is he like mad about? He is mad that the transfer encoding is not chunked. I see. So it looks like this is actually completely unrelated to the debug data writing, and only the fact that I fucked up this AnyWriter. That's my guess. That's my guess, but we'll see. So let's take out this stuff and just double check how fucked it is. Refresh. Yep, still fucked. So is it that, like, why, what did I change in the server? I feel like I didn't really change anything that was that relevant. Response, writer, and then we take the writer. So let's just double check right now. If I take this and I don't use that AnyWriter and I just use the writer directly here, I assume that that's fine. Yeah, that seems fine. So why is this different? Maybe this has to be a ampersand? No, like I don't understand. I'm clearly using the AnyWriter wrong. Usually just call any to get one. Oh, let's try that. Maybe I'm using it wrong. So this guy does pointer cast, self-context, type erased write function. Ah. So I'm surprised that it compiled that way before. No function any? Why is there no function any? Oh, he's maybe already an AnyWriter. Maybe he's already an AnyWriter. Okay, so do I get back debug data? No. But here, I can do this. Okay, so now we're crashing again, but now it's at somewhere more reasonable. It's because we are fucking up our JSON writing in the serialization here. So here, k means clusterer, serialize debug data. So begin object, end object. Begin array, end array, begin object, end object. So what's he complaining about? They all match up with each other, but he's mad at 344. No, I don't really see why he should be mad. He's kind of saying that there's not a matching open tag, I think, is what he's complaining about. So I guess we'll just maybe start commenting out like k means cluster. Maybe we'll start commenting out like the insides of this function and just see where it starts where it's broken. So we'll start here, right? He's gonna get mad because of all these unused fucking things. So I guess we'll start by just making an empty object. I expect this to work. And we will say ignore the fact that self is unused for now. So I expect this to work. No, but it doesn't. Surprising. So why the fuck not? Why? So here, all we do is write an object. Okay. So let's uncomment this and this, right? Uncomment this, we're chilling. No one's mad. Now let's say we uncomment this, and what if we just try to like add object or begin object and end object right here. Like, I would think that this is fine. This should, I would think, go to like debug is equal to this. That's what I would think happens here. So let's just see if that's okay. Refresh. Yeah, that's also fine. So here we have debug is an object. Great. No problemo. So how come if I call this instead, he passes in JSON writer. I go to my serialized debug data implementation, and all this guy's doing is the same thing, a begin and end object. Right? Like, am I high? I feel like we're not doing anything different. But now all of a sudden he's like, oh, I don't like that. Like, why? You know? You know? I feel like I'm missing something very obvious. Like, maybe I'm copying somewhere that I'm not supposed to. This is taken by pointer. That's taken by pointer. 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 Yeah, everything's by pointer. So, like, I don't see why the state would be any different. Let's get a little crazy. And let's just, in this function, do the same thing. Right? Like, I don't believe that that should be a problem. But I don't believe the way it is right now should be a problem. Yeah, so that's fine. Right? This is also fine. He's just making an empty object here. So I guess we just keep fucking bisecting. Which is fucking stupid, but... You know? Oh, wait, hold on. If this guy doesn't write anything, that's what it is. So he's not writing anything. So in this case, if it's not implemented, we have to write some empty garbage. Ah, so we weren't even getting here. Okay, let's try that. Let's try that. Okay, so now we're chilling. And if we go to k-means now, and we look at our data. Oh, hell yeah, baby. So if we go to like our agglomerative cluster, we have just empty debug data. But if we go to our k-means cluster, we have something to work with. Hell yeah. Okay. Let's get a longer running thing of our server up. Give him a sec. We need to, I don't know what the fuck it's doing, but it's doing something. And he's got to think. You know, he's thinking. It's hard for him. His brain hurts. But we gotta give. Holy shit, that takes so long. Okay, so if we go to our index.js now what we can do is we can start getting crazy in here, and in our re-render, we can say maybe we look at our data, and if here's my data, my JavaScript's gonna fucking fall over here. JavaScript object has field property. They're called properties here. Original answer. Type of this property. Is this, what the fuck? How come I've never seen any of this? Has underscore.js. Ugh. Has own property works for, like, what the fuck? Can I, like, I guess what I would normally do is I would check if like data debug type is equal to undefined. Or maybe we just do like a double string equals with k-means, because this will return false if it's not there. Maybe. Then we walk the means. So for let mean of data debug means, I think that's good enough. And then we can just draw on our canvas. Okay, like maybe we'll draw like a square at that point. I guess we actually want the index. So we write in instead of for some fucking reason. I don't really know JavaScript, so you know, I should look up the in and of at some point. It seems like really important. But instead, I'll just continue to be fucking confused all the time. How about that? Okay, so now we have the mean index here, and we'll say let const mean is equal to data debug means at mean idx, and we'll say const color is equal to cluster colors at mean idx, and then we can just do something like draw a rectangle at a certain point. So we can say like ctx draw rect fill rect at a given x and y location, so mean x and mean y, as well as maybe we'll draw like a 3x3 rectangle with the given color. Except it's not with a given color, it's ctx. There's some way to set this, and I don't know what it is. ctx style, fill style is equal to color. Maybe. K-means. We're close. We have 3 really tiny things in the top left, so we forgot to scale. So it's like this. Because the canvas is not the same size as the data, because the data is fucking small. So here we say times canvas scale plus canvas offset. Refresh. Go back to k-means. And we can't really see them, but what if we make them very big? Like, just like 100 by 100. Like, let's get fucking crazy. Okay. We have 2 servers running, which is kind of funny. So we were just kind of like flip-flopping between 2 different things, but that's close. I think that it's actually drawing from the top left of the rectangle. That's just like what it looks like from what I'm seeing here. If we assume that the code is right, which I always do. Let's try that. Right? I've never written a bug in my life. That's what I always say. Okay, so it does look like that's working, and so now can we add like a border around them so that they're easy to see? So ctx dot like stroke style. Can we say that this is like black? And can we like set its width or something? I don't really know how this works. Maybe instead of just guessing, we should look it up. So HTML canvas rect like I want like this, but oh here, so line width, stroke style, and then fill style, I bet. So I can say ctx like line width. Can we just make this like 10 or something? Just as an example. Does fill rect not? Maybe I have to do rect and fill rect so that I get both. No? Am I high? I just want a box with the border. HTML fill rect. What language do I use at my day job? Well, right now I'm unemployed, which is pretty sick. But what's it called? Fun employed. We're unemployed by choice. But like our previous jobs, I did C and C++ because I was working on like camera firmware. So the firmware user space was written in C++, but like we write like kernel drivers and stuff too. So those were in C. It was running on Linux. And then like there was like some like microcontroller shit in there too. So that was all C as well. Sometimes C++ actually. Sometimes I think that the microcontroller. We had one C++ microcontroller project, one C. And then I worked at another job where I basically wrote a bunch of Python mostly, because it was like machine learning stuff. And machine learning bitches love Python, which makes sense, right? The ecosystem's pretty strong. But, you know, in there you're dropping down to C++ as well. C++ user space app. Yeah, so I think that's it. No Rust, no Zig at work ever. But a lot of C++. I don't think I've ever written any Java at work. I've done like, you know, handfuls of JavaScript and HTML for like web UIs for firmware and stuff, or like debug visualizations for stuff. Like one thing that was kind of fun is like you can like generate like reports for like stuff that happened, and you can just like spit out an HTML file, and then like it's really easy, just like click on the HTML file and you get like, you know, you can like embed some like diagrams and shit in there without having to like run a server or something. They can just be sitting in a folder. So stuff like that. Nothing like crazy. No real web dev, just kind of like good enough web dev. You're saying I can just use rect, but this thing doesn't like fill. I want both a filled rectangle and an unfilled rectangle. So maybe if I do both, but I do the filled one first, the unfilled one will be drawn on top? Maybe. Still not. I feel like I'm like losing my fucking mind. Line width 10, stroked out like. Okay, let's just get rid of the filled rect for a second. Let's just do a normal rect and see what happens. K means like. K means. Right, like I'm not seeing a rectangle at all. Why the fuck not? Oh well, I am running the server twice again, which is never good. Yeah, but I'm just not seeing the rectangle. Like, what the fuck? What the... So here I have to say... stroke. I've got to stroke my rect. That's what they always say. There we go. And so now I can go back to having a filled rect as well, with the same parameters. Or maybe I just do a fill rect and then I stroke it. That would make sense to me. No, the stroke is making a circle down here. So I do have to then stroke my rect, but not my full rect. Oh, that's coming up. Okay, so I did mean for that to be a little bit dirty, but not that dirty. You know? I'm fucking running the server twice again. How to have it. Okay. There we go. That's looking good. Oh, so kind of interesting. The stroke is applying to like multiple things at once. So I guess what happens is when you say ctx rect, that like pushes into some buffer of things, and then later you stroke everything that you've pushed into your buffer at once. So here I probably actually want to say like ctx like clear. I want to like reset it in some way. In path. Probably. There we go. Yeah. Nice. And now I can make them smaller and I'll be able to see them. So we'll say const width or rect size is going to be, let's make them like, you know, 20 for now. And we will say here, we'll say rect size over 2. This is rect size over 2, rect size over 2, rect size over 2. This is rect size. Boom, 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 boom. Okay. And now we should see as we step, we can kind of see move around. Oh, interesting. So, we can kind of see that, like, oh, that was kind of fun. We did see him finally split one of them. But I think, like, there are some situations in here where the initial guesses result in something that doesn't actually work. That one was fine. That one was fine. But I think we saw a case where, yeah, like this. So we have 3 actual clusters here, right? There's one here, and one here. And what's ended up happening in this scenario is that because 2 of our clusters, like 2 of our initial guesses started in this like tiny cluster here, this cluster didn't get split up the way we would have wanted it to, right? Like, so here, if we use Diana, here we're like guaranteed to get these 3 clusters because he's always going to split based off of like diameter of the cluster. But with k-means, like, it just depends on where this red dot hits. That's interesting. So there he happened to hit okay. So let's try again. Right, like, so here, what ends up happening is this blue one doesn't get split. So that's pretty interesting. Pretty interesting. So why is this, like, when I Googled, like, what clustering algorithm should I use, why is this one at the top? This seems like the worst one so far. Compared to, like, I guess maybe if we could experiment with, let's say we have like one cluster that has like one very large radius. I could imagine that k-means clustering will do a good job of splitting this into... That's weird. Why am I rendering off the screen? What's happening here? Something's wrong. My points are going, like, out of my canvas. Why? This shouldn't be happening. Okay, there's a bug somewhere. Let's look at that. K-means is actually the only clustering algorithm I've ever heard of. That's kind of what I'm saying. It seems like the worst one. Okay, why are our points? What is our point randomization doing? Generate points. So we take in like some amount of clusters and a cluster radius. Oh, it's because we had a hard-coded cluster radius of like 25 before, and that's not true anymore. So here we have to say that the center of our thing is cluster radius, and on the right side it's 100 minus cluster radius, and 100 minus cluster radius, and we have to limit our cluster radius at 50. So if cluster radius is greater than 50, return error dot invalid radius, and we'll just say std log error. We will say invalid data, so it's a kind of more common error, and we'll just log cluster radius must be less than 50. Sure. Okay. So now we can rerun this thing. Except he doesn't succeed because cluster radius probably has to be int cast here. Maybe we'll just... Oh, yeah, it's fine. Maybe we'll... Yeah, it's fine. Int cast. Yeah, it's fine. I don't know. Const cluster radius I32 is an I32 equals int cast float int from float. There it is. Cluster radius. Okay. And then here we'll just use cluster radius I32. And I know this isn't perfect, but I don't want to think about it right now. And I think I'm also noticing in some cases like a non-freed thing. Probably because in our k-means clusterer, on free, we are not clearing out our internal state. So we have to say self means d init like this. Okay, let's try that again. So we go to k-means. And let's make our cluster radius 50, and we'll make one cluster. And now, hopefully, these things are rendering mostly inside. Even this feels wrong. My radius could be anything between float. Is float norm always between 0 and 1? No, it's not. It's not. It's not. It's not. It's not. Ugh, fine. I'll just make the radius smaller. There we go. There we go. That's good enough. Okay, so here I could see an argument that k-means clustering will bisect data like this a lot better. Right? Like that isn't actually in groupings. Because it will just kind of like shift itself around until kind of you have like an even split. Where's my red? That was weird. But like, and like, what's like Diana gonna do in this scenario? Like, I guess that still seems kind of sane to me. He's kind of taking like the items that have some objects that are far apart from each other and splitting them up. So I think that's still reasonable. Yeah, like those are reasonable clusters for this, where like a k-means is... I guess we're kind of saying that k-means is where we've hard-coded 3 in here, so it might not be super reasonable. Interesting. But yeah, I mean, this like cluster radius 2 num clusters 5, like, or 3 would happen to match up. Like this definitely has some like bad cases in it. Obviously we want 2 where like the 2 of the clumps land really close to each other. And then we reinitialize this guy a few times. Yeah, like this. Like this will just never fix itself. Interesting. Interesting. Okay. So that's good. We're an hour and 30 in. Do I think that I'll get DB scan in time? I think there's like a good chance that I won't. So I think what that means is I'm going to call it here for today. A little bit of a shorter one today, but we haven't had a short one for a while, so I think it's okay. Yeah, thanks for watching, guys. Had fun today. What do we do? We basically just implemented k-means clustering. We didn't really do much else. And we've got a bit of a feel for it now. Feels okay. I can't imagine me using this for anything, to be honest. Like, it just doesn't feel... It feels so non-deterministic and flaky. So, anyways, we'll see. If you like what you saw, we stream most days at around 2 o'clock Pacific time. We're streaming for usually around 2 hours. So if you're online between 2 and 4 Pacific time, it's 3:30 now. So between 1.5 hours ago and half an hour from now, you can swing by, see what we're up to. There's a YouTube link and a GitHub link in the Twitch description. So that has VODs of all previous stuff. We have previous projects organized as playlists, things like Rust operating system, terminal emulator, virtual file system, some like neural network stuff, a small amount of web dev, stuff like that. What else? We're working on a QR code scanner right now. So we're going to hit a couple more clustering algorithms and then probably jump back onto trying to actually parse something like this. Yeah. If you're watching on YouTube, there should be a Twitch link in the YouTube description. You can swing by and say hi if you feel like it. Otherwise, thanks for watching, and I'll catch you guys in the next one. Bye. Have a good weekend.